Hi everyone. Well, we've got another lesson this time on diamond formation. And this is something that I think is always fascinating. Diamonds are absolutely gorgeous. And the question is, what kind of conditions do you need? What kind of temperatures and pressures inside the earth will form a diamond? And then there's the question of, can humans make diamonds? The answer is yes. We've been doing it since World War II. All right, so what I've done is there is a Google Doc that I'm going to be sharing with you. And what I want you to do is try and go through it, look at the diagram, answer the questions that are present. This is where it gets a little tricky, especially if you just have a Chromebook and you don't have any internet. One of the things that I tried this morning was I took a picture of the graph that was in the Google Doc. So I had it on my phone, and then this way I could refer back to the questions. And in the Google Doc, you are able to put your answers. So that's what I'd like you to try and do first, okay, before you look at the rest of the video. It's always more fun to do it first. And then here are my answers so you can check yours once you get them done. Please don't just copy them. Like I said, try it yourself. All right, so you see the graph that's on this slide here. And what you notice here as temperature, as you go deeper and deeper inside the earth, the temperatures will start to go up. So the first question says, solid line shows how temperature changes within the earth. As you go deeper in the earth, does the temperature increase or decrease? And the answer is definitely increases. All right, and this is due to radioactive elements that are present inside the earth. Sorry, I got a phone call. I'm just going to turn that off. All right, number two, the dashed line shows the boundary between graphite and diamond. Cross this line, the carbon in graphite becomes diamond. As the temperature increases, does it take more or less pressure to make a diamond? Well, the obvious answer is it takes more, right, as you can see from the way that the line is slanted. Number three, where the solid and dotted lines cross, diamonds will start to form. At what temperature do diamonds form inside the earth? All right, so right here is what we call the critical temperature. And if you run your finger, I'm going to use my pointer up here, you'll notice that it hits the x-axis around 1,000 degrees Celsius. So that's what I'm looking for, about 1,000 degrees C. Number four, we don't tend to think in terms of degrees Celsius. We tend to think in terms of Fahrenheit. So what would that be in Fahrenheit temperatures? And I gave you the formula. Fahrenheit temperature is equal to 9/5 times the temperature of Celsius plus 32. So if you take 1,000 times 9 divided by 5 and add 32, you end up with 1,832 degrees Fahrenheit. So you need very high temperatures in order to make a diamond. Number five, what is the pressure in kilobars that you need to make a diamond? All right, well, this is a tricky question. We need to break it down. All right, so the first thing is, what is a kilobar? Well, think about your metric prefixes. Kilo means 1,000. All right, so it's 1,000 bars. And a bar is atmospheric pressure at sea level. All right, so once we know that, okay, then what we can do is you come over here to the critical point, run over, and it looks like it's a little more than 40. So I estimate it's around 50 kilobars. If we want to convert this into tons per square inch, tons of force per square inch, what we're going to do is take this answer in number five. We'll multiply it by 15,000 because there's 1,000 bars in a kilobar. Then times 15, which is the normal atmospheric pressure, you end up with 750,000 pounds of force you need per inch. If you want to get that in tons of force per square inch, you divide it by 2,000, and you end up with 375 tons of pressure to create a diamond. So obviously it takes very high temperatures, very high pressures inside the earth to create these beautiful crystalline substances. Number eight, at what depth do diamonds form? All right, so now what we do is we take the critical point here, and we're going to run it over to this side of the diagram, and we end up at 150 kilometers about. Number nine says, let's convert this to miles. So we do that by multiplying by 0.6. And we end up, you got to go about 90 miles down in the earth, okay, to get to diamonds. Number 10, since the lithosphere extends down from the surface of the earth to 120 miles, do diamonds form in the lithosphere or the asthenosphere? And the answer is obviously the lithosphere. Number 11, do diamonds form in the crust or the mantle of the Earth? Well, remember, the crust only goes down about 20 miles into the Earth, so diamonds typically form inside the mantle. So next question says, number 12, did the right temperature and pressure conditions ever exist in Rocky Mount for the formation of the diamonds? Well, the answer is no, but we probably got pretty close. If you go on the north side of town, you can find garnets. And what pressure do we need for garnets? Well, garnets are indicated by these little circles here. The diamonds are the diamonds. So it's about 40 kilobars you need of pressure. Number 13. So if we take graphite and take it to the same temperature and pressure conditions that diamonds form in the Earth, would we get man-made diamonds? The answer is no. And the reason is that inside the Earth there's no oxygen. And what happens is if you have graphite down there, it's not going to burn. If you try and do it on the surface of the Earth in an oxygen-rich environment, it's going to be like charcoal. It's going to be like a big barbecue pit, and it's going to catch on fire, and you're just going to get ash. But the good news is there is a better way of doing it. Instead of raising the temperatures, drop them as far as you can down to 0 degrees Celsius. And when you do that, you're going to find out you only need about 20 kilobars of pressure. And if you convert that to force per square inch using the method we did above, you multiply by 15,000, divide by 2,000, you end up with 150 tons of pressure per square inch. And those are achievable today. All right, so like I said, what I want you to do is put these answers into the Google Doc to show me that you've done this work, and then share it with me, and so I can give you credit for this activity. Thank you.